This is a quick introduction to what we're doing next, which is called geometric probability. So what is the difference between the following two scenarios? What is the probability that Jerry makes 4 free throws out of 10 attempts versus what is the probability that Jerry makes his first free throw on his 4th attempt? So I'm hoping you're seeing that there's a change within the wording here of the question. Here it looks like we have a desired number of successes of 4 free throws. So that's x equals 4 made free throws out of a total of 10 attempts. That's n. 10 is the total number of trials. So we want the probability of x equals 4. 4 free throws in out of 10 attempts. And then the second one says he makes his first free throw, excuse me, on his 4th attempt. So I'm hoping that you guys notice that the first one in is going to be on the 4th trial. And this is a shift in perspective. In this second scenario, there is no specified n. So with A is a binomial setting, and it satisfies the 4 conditions of the binomial setting. It has a finite number of trials. Specifically, that's the most important one, 10 attempts. And then also each shot falls into one of 2 categories, success or failure, made or missed. Each shot is independent of the next, we assume, and the probability of success will remain the same from trial to trial. But in this next one, it sounds like we're waiting until Jerry makes his first free throw. So that would be 1, 2, 3, 4. We're waiting until success. Waiting until success. So it's going to be failure, 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 success. So the difference here is that they're not specifying the total number of trials that he makes, and we're not specifying or spotlighting the total number of successes out of the trials. It's a different shift. So this is now called a geometric setting, and it happens when we specifically are looking for the trial number of the first success, okay? So in the case of the binomial setting, x represented the number of successes. So if you look back at this one, the x represented 4 successes, 4 made free throws out of 10. But here, when you look at x equals, it's going to actually represent the trial number of the first success. So in the case of Jerry, that would mean that probability x equals 4 would not mean that he has 4 total successes. It would mean that the 4th trial would be the first success. Hence, failure, 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 success. Okay, so it's a little shift in perspective here. So keywords that you can look for are if they say the first, free throw made in, that would be one. If they use the word until, that's another one. Things like that. The trial number of the first success. So here is an example, and then we will be done. A college basketball player makes 80% of his free throws or her free throws. So we're going to let P equal 0.80, and that's made free throw. Okay, suppose the probability is the same for each free throw, so that means that they're independent of each other and that the probability of success is going to remain the same. They're not changing from trial to trial. What is the probability that she doesn't make a free throw until her 5th attempt? Okay, so basically there's that keyword until, and her first made basket is going to be on the 5th attempt. So we're going to let P x equals 5 represent the 5th attempt is the first basket made in, first success. Okay, so this actually 1, 2, 3, 4, 5, this is going to be failure, 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 success. So basically it's 4 failures and then 1 success for 5 total trials. So if you think about it that way, it's going to be failure and failure and failure and failure and success. Or failure to the 4th power, because there's 4 of them, 1, 2, 3, 4, times success to the first power because there's one of them. So basically in this case, if we have probability of success is 0.80, the probability of failure, which is 1 minus p, is going to be 0.20, which is a missed free throw. So those two have to add up to one whole, just like they did in binomial setting. So we would do failure, 0.20, times 0.20, failure, 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 success. Or rewriting it as 0.20 to the fourth times 0.80. This is going to give us our answer. So if we put it in the home screen in our calculator, just like this, you're going to see 0.20 to the fourth. I have an extra parentheses in there, but it should be okay. Times 0.80 to the first. And that's going to be 0.00128. Okay, so there's a 0.128% chance that she will not make it her first free throw until her fifth attempt. Now, the other thing that we can do is we can use geometric PDF. So just like we had binomial PDF, we can also do geometric PDF. So to get there, we could press second vars, up or down. I like up, and go to letter F for Frankfurter, and put in P, which is 0.80. And put in the X value, which is going to be the first trial of your the trial number of your first success. So notice they don't ask you for the trial numbers here, which is N, because we don't have the trial numbers. We're just waiting until she gets success. So I could be here all day trying to get the basketball in and never make it in, right? I could just do infinite shots and never make it in. But they're saying she's going to make it in on her fifth attempt. So this X is representing the fifth trial is the first success. So we still get the same answer, 0.00128. So for the geometric setting, I do recommend that you kind of just write it out so you can visualize what's happening here. 4 failures and then a success. I think that actually makes more sense logically than using the calculator, but the calculator is a nice check. We're going to be expanding on this tomorrow, but at least there's the foundation. The difference is the binomial setting has a finite number of trials, n, that's the key. And then the geometric setting, which is the second one, does not have a finite number of trials. That's it.